Alright, I'm in the private oral exam guide. I'm going to be in Chapter 2, Weather. This will be 2-3, Nature of the Atmosphere. State the general characteristics in regard to the flow of air around high and low pressure systems in the northern hemisphere. Low pressure is inward, upward, and counterclockwise. High pressure is outward, downward, and clockwise. So low pressure, low is inward and upward and counterclockwise. High pressure is outward, downward, and clockwise. What is a trough? A trough, also called a trough line, is an elongated area of relatively low atmospheric pressure. At the surface, when an air converges into a low, it cannot go outward against the pressure gradient, nor can it go downward into the ground. It must go upward. Therefore, a low or a trough is an area of rising air. Rising air is conductive to cloudiness and precipitation, hence the general association of low pressure and bad weather. What is a ridge? A ridge, also called a ridge line, is an elongated area of relatively high atmospheric pressure. Area moved out of a high or ridge depletes the quantity of air. Therefore, these are areas of descending air. Descending air favors dissipation of cloudiness, hence the association of high pressure and good weather. What are the standard temperature and pressure values for sea level? 15 degrees Celsius and 29.92 HDR, millibars of mercury. What are isobars? An isobar is a line on a weather chart which connects areas of equal or constant barometric pressure. Number 6. If the isobars are relatively close together on the surface weather chart or constant pressure chart, what information will this provide? The spacing of isobars on these charts defines how steep or shallow a pressure gradient is. The isobars are spaced very close together. A steep gradient exists, which indicates higher wind speeds. Shallow pressure gradient isobars not close together usually means wind speeds will be less. What causes the winds aloft to flow parallel to isobars? The Coriolis effect. Coriolis force causes the winds aloft to flow parallel to the isobars. Coriolis force. Why do surface winds generally flow across the isobars at an angle? Because of surface friction. At what rate does atmospheric pressure decrease with an increase in altitude? 1 inch of mercury per 1,000 feet. What does dew point mean? Dew point is the temperature to which a sample of air must be cooled to attain the state of saturation. Dew point is the temperature to which a sample of air must be cooled to attain the state of saturation. When temperature and dew point are close together within 5 degrees, what type of weather is likely? Visible moisture in the form of clouds, dew, or fog. Also, these are ideal conditions for carburetor icing. What factor primarily determines the type of vertical extent of clouds? The stability of the atmosphere. How do you, Dougie, determine the stability of the atmosphere? No response. Unstable air is indicated when temperature decreases uniformly and rapidly as you climb, approaching 3 degrees Celsius per 1,000 feet. If temperature remains unchanged or decreases only slightly with altitude, the air tends to be stable. Instability is likely when air near the surface is warm and moist. Surface heating, cooling aloft, converging or upslope winds, or an invading mass of colder air may lead to instability in cumuliform clouds. Number 14. List the effects of stable and unstable air on clouds. Turbulence, precipitation, and visibility. Clouds. A stratiform is stable. A cumuliform is unstable. Turbulence. Smooth is stable. Unstable is rough. Precipitation. Stable is steady precipitation. Unstable is showery. Visibility. Stable air is fair to poor. And unstable, it's good. Stable is stratiform, smooth air, steady precipitation, and visibility is fair to poor. Unstable is cumuliform clouds, rough turbulence, showery precipitation, and good visibility. Number 15. At what altitude above the surface would a pilot expect the base of cumuliform clouds if the surface temperature is 82 degrees and the dew point is 62 degrees? Oh, I know how to do this one. It's going to be some 4.4. Yep, there it is. All right, you can estimate the height of cumuliform cloud bases using the surface temperature and dew point spread. Unsaturated air in a convective current cools about 5.4 degrees Fahrenheit, 3.0 Celsius per 1,000 feet. Dew point decreases about 1 degree Fahrenheit. Thus, in a convective current, temperature and dew point convergence at about 4.4 degrees Fahrenheit per 1,000 feet. You can get a quick estimate of convective cloud bases in thousands of feet by rounding the values and dividing them into a spread. When using Fahrenheit, divide by 4 and multiply by 1,000. This method of estimating is reliable only with instability clouds and during the warmer part of the day. So you'd be temperature minus the dew point divided by 4. Times 1,000 equals the base of clouds. So temperature 82 minus the dew point of 62 equals 20. 20 divided by 4 is 5. 5 times 1,000 equals 5,000 feet cloud bases above ground level. There's number 15. During your pre-flight planning, what type of meteorological information should you be aware of with respect to icing? Locations of fronts. A front location, type, speed, and direction of movement. Cloud layers. The location of cloud bases and tops, which is valuable when determining if you will be able to climb above icing layers or descend beneath those layers into warmer air. Reference the PREPs and area forecasts. C. Freezing levels. Important when determining how to avoid icing, how to exit icing conditions if accidentally encountered. D. Air temperature and pressure. Icing tends to be found in low pressure areas and at temperatures at or around freezing. Number 17. What is the definition of the term freezing level and how can you determine where that level is? The freezing level is the lowest altitude in the atmosphere over a given location at which the air temperature reaches 0 degrees Celsius. It is possible to have multiple freezing layers when a temperature inversion occurs above the defined freezing level. Pilot can use current icing products, CIPs, and forecast icing products, FIPs, as well as freezing level graphics charts to determine the appropriate freezing level. Other potential sources of icing information are area forecasts, pre-reps, airmets, sigmets, surface analysis charts, low-level significant weather charts, and wind temperatures allow for air temperature altitude. What conditions are necessary for structural icing to occur? Visible moisture and below freezing temperatures at the point moisture strikes the aircraft. Name the main types of icing aircraft may encounter in flight. Get some structural icing, induction icing, and instrument icing. Name 3 types of structural icing that may occur in flight. Get some clear ice, forms after initial impact when the remaining liquid portion of the drop flows out over the aircraft surface, gradually freezing as a smooth sheet of solid ice. Get your rime ice, forms when drops are small, such as those in stratified clouds or light drizzle. The liquid portion remaining after initial impact freezes rapidly before the drop has time to spread out over the aircraft. Mixed ice. Forms when drops vary in size or when liquid drops are intermingled with snow or ice particles. These ice particles become embedded in clear ice, building a very rough accumulation. What action is recommended if you inadvertently encounter icing conditions? The first course of action should be to leave the area of visible moisture. This might mean descending to an altitude below the cloud bases, climbing to an altitude above the cloud tops, or turning to a different course. Number 22, is frost considered to be hazardous to flight and why? Yes, because while frost does not change the basic aerodynamic shape of the wing, the roughness of its surface spoils the smooth flow of air, thus causing a slowing of airflow. This slowing of air causes early airflow separation, which results in loss of lift. Even a small amount of frost on airfoils may prevent an aircraft from becoming airborne at normal takeoff speed. It is also possible that once airborne aircraft could have insufficient margin of airspeed above stall, so that moderate gust or turning flight could produce incipient or complete stalling. 23. What factors must be present for a thunderstorm to form? Sufficient water vapor, water vapor, unstable lapse rate, and initial upward boost lifting to start the storm process in motion. So, what factors must be present for a thunderstorm to form? A is sufficient water vapor, B an unstable lapse rate, and C an initial upward boost lifting to start the storm process in motion. Cool. Wow, there's a lot. 24. What are the three stages of thunderstorms? Cumulus stage, updrafts cause raindrops to increase in size. Mature stage, rain at Earth's surface. It falls through or immediately besides the updrafts, lightning, perhaps roll clouds. Dissipating stage, downdrafts and rain begin to dissipate. What is a temperature inversion? An inversion is an increase in temperature with height. A reversal of the normal decrease with height. An inversion is an increase in temperature with height. A reversal of the normal decrease with height. An inversion aloft permits warm rain to fall through cold air below. Temperature in the cold air can be critical to icing. A ground-based inversion favors poor visibility by trapping fog, smoke, and other restrictions into low levels of the atmosphere. The air is stable with little or no turbulence. State two basic ways that fog may form. Cooling air to the dew point. Adding moisture to the air near the ground. Name several types of fog. Radiation fog, advection fog, upslope fog, precipitation-induced fog, and ice fog. What causes radiation fog to form? The ground cools the adjacent air to the dew point on calm, clear nights. What is advection fog and where is it most likely to form? Advection fog results from the transport of warm, humid air over a cold surface. A pilot can expect advection fog to form primarily along coastal areas during the winter. Unlike radiation fog, it may occur with winds, cloudy skies, over a wide geographic area and at any time of the day or night. So it's advection fog results from the transport of warm air, humid air over a cold surface. What is upslope fog? Upslope fog forms as a result of moist, stable air being cooled adiabatically as it moves up sloping terrain. Once the upslope wind ceases, the fog dissipates. Upslope fog is often quite dense and extends to high altitudes. Define the term wind shear and state the areas in which it is likely to occur. Wind shear is defined as the rate of change of wind velocity, direction, and or speed per unit distance. Conventionally expressed as vertical or horizontal wind shear and may occur at any level in the atmosphere, but three areas are of special concern. Wind shear with low level temperature inversion, wind shear in a frontal zone or thunderstorm, clear air turbulence CAT at high levels associated with a jet stream or strong circulation. Wind shear is defined as the rate of change of wind velocity, direction, and or speed. Why is wind shear an operational concern to pilots? Wind shear is an operational concern because unexpected changes in wind speed and direction can potentially be very hazardous to aircraft operations at low altitudes on approach to and departing from airports. What types of weather information will you examine to determine if wind shear conditions might affect your flight? 33A. Terminal forecast. Any mention of low-level wind shear, LLWS, or the possibility of severe thunderstorms, heavy rain, showers, hail, and wind gusts suggest the potential for low-level wind shear and microbursts. Meteorites. Inspect for any indication of thunderstorms, rain, showers, or blowing dust. Additional signs such as warming trends, gusty winds, cumulonimbus clouds, etc. should be noted. That's 33. C. Severe weather watch reports, segments, and convective segments. Severe convective weather is a prime source for wind shear and microbursts. Low-level wind shear alert system reports installed at 110 airports in the U.S. designed to detect wind shifts between outlying stations and a reference center field station. PIREPS. Reports of sudden airspeed changes on departure or approach and landing corridors provide a real-time indication of the presence of wind shear. Alright, so we'll hold off right there. That was Chapter 2. That's a Chapter 2-3 to 2-10. That is in Chapter 2 Weather. That's all section A. See ya.